Let's start with this problem. Find a mean, median, mode, and range of the following dataset. Now, the first thing that I would recommend doing is arranging the numbers in increasing order. So the lowest number is 7, and we have 2 of them. After that, the next number is 10, and then 14, 15, 23, and 32. Now, to calculate the mean, what we the 7 numbers that are in the data set. So this is going to be 7 plus 7 plus 10, and so forth. And then we're going to divide it by the 7 numbers. So the mean is basically the average of those numbers. So the total sum that I got is 100. In this video, we're going to talk about how to use the Poisson distribution formula in order to In this video, we're going to talk about how to calculate the probability of a binomial distribution. So here we have a problem where a 6-sided die is rolled 12 times. What is the probability of getting a 4 5 times? So here's the formula that we need. The probability of getting x successes is equal to the combination formula ncx, which can be written that way,
n minus
times p raised to the x times q raised to the n minus x. So as step 4, capital P of x is the probability is the get a 4 5 times, so there's 5 successful events that we're trying to achieve. Now what is the probability of getting a successful event? What is the probability of rolling a 4 using a 6-sided die? So out of 6 numbers that we take out of 6, 12 factors, P count a 4. A multiple choice test contains 20 questions with answer choices A, B, C, and D. Only one answer choice to each question represents a correct answer. Find the probability that a student will answer exactly 6 questions correct if he makes random guesses on all 20 questions. So go ahead and take a minute and try this problem. So let's begin with the form.
With 6 p raised
So it's going to be ncx
p raised by 6
times the minus x. Okay, so now that I'm going to answer B. What's this problem? I made a mistake. If I take 5 answer choices, P and Q will be different. If there were 5 answer choices, P will be 0.20. More students are chosen at random. Part A. Find the probability that exactly 7 students out of the 30 chosen are taking algebra. Go ahead and work this problem.
Next. %. Integral. That's a choosing number E. So say 7 out of 7. That is 7. 7 plus budget 3. Which is x cubed by x cubed. It's very easy to figure. Fewer than 5 students. So that is right of 2 plus values of 3 plus values of 4. Really mean is the mean is standard deviation of binomial distribution. Is the mean so standard deviation with binomial distribution. So that is the mean is NP. It's something like this. So, something explain.
So we're going to use the same formula as we've been using in the last 2 problems. So what is n in this problem? N is going to be the number of students that are chosen at random. That's 30. X is going to be the number of successes in n trials. So these are going to be the number of students who are taking algebra out of the 30 chosen. So X is going to be 7. P is the probability of selecting a student who is taking algebra. And that's going to be 25% or 0.25. That's 0.24. What is the probability of just one student that get 0 of, as you only have to count Rates are very this and deviate between 37 and 17 for this video. Now, how would you answer this question? What is the probability of getting the first 6 on the 4th row using a 6-sided die? You need to realize that
First 6. Hmm. Shit. It is times there is geometric distribution 8 times n minus x minus 1. Geometric distribution. X minus 1. Where is the other? See?
this is a geometric distribution. You try to find a probability that a successful event will occur in the 4th try. So during the first roll, you're going to get a failed event. During the second roll, it's another fail. But during the 4th try, you're going to get a successful event. These are 12 by 6 and 9 that you want to get a successful event. This is going to equal to q raised to the x minus 1 times p. Now, lowercase p is the probability of getting a successful event. Q is the probability that an event will fail. Now keep in mind, q is 1 minus p. So in some textbooks, you'll see it written like this. So just keep that in mind. So if we apply this formula in this problem, we have capital S, the random variable, little s, that's going to be 4, because we want to get a successful event on the 4th row. Q is the probability of not getting a 6, which we said is 5 over 6. X is 4, so this is going to be 4 minus 1, times probability of getting a successful event, in this case, successfully rolling a 6, that's 1 out of 6. And so as you can see, this will give us the same answer, which is going to be 0.09645. But that's how you can use the formula in order to calculate the probability of a geometric distribution. Number 2, 15% of all cars passing along a certain road are blue. What is the probability that the 7th car will be the first blue car that you see passing along this road? So let's write the formula first. So the probability of successfully seeing a blue car is 15% or 0.15 as a decimal. So the probability of not seeing a blue car, it's going to be 1 max sub is 0.8, not the 8. Here we go. That means that 96% of the population. Are not teachers. So to get to a 10, ultimately teach them, it's going to be 1 sigma squared, 4. That we need to calculate is this time. For this product is produced by company XY's variance is 25 times 0.04 is 0.96. 10 minus 1 is 9. And P is 0.04. So that's 0.96 raised to the 9th power times 0.04. So this is equal to 0.0277. So there's approximately a 2.77% chance that the 10th person that you encounter in this town is going to be a teacher. Now let's move on to part B. Let's calculate the mean, variance, and the standard deviation. So let's start with the mean. The mean is 1 over P. So it's going to be 1 over 0. 0.04. The variance is P is the mean, as we can see here. So 1 over P is 25. 0.04, and that is 25. Now what about the variance? There's a simple formula that we could use to calculate it. It's sigma squared, which is 1 over P times 1 over P minus 1. Now keep in mind, 1 over P is the mean, as we can see here. So 1 over P is 25. And then times 1 over P minus 1, that's 25 minus 1. So this becomes 25 times 24, which is 600. So that's the variance in this problem. Now the last thing that we need to calculate is the standard deviation. The standard deviation is the square root of the variance. So in this case, it's the square root of 600. And that's going to be 24.49. So that's it for this problem. That's how you can calculate the mean, variance, and the standard deviation. Number 4. 2% of all tires produced by company XYZ has a defect. A random sample of 100 tires is tested for quality assurance. What is the probability that the 8th tire selected has a defect? So go ahead and take a minute and try the problem. So let's write down what we know. So what are the values of P, Q, and X in this problem? Well, 2% of all tires has a defect. So P is 0.02. That's the probability of selecting a defective tire. The probability of not selecting a defective tire is going to be 1 minus 0.02. Selected has probability we need to count X is 1 equal to 1 plus 0.9. X equal to that will get to X 0 T. So the values which if the tire number is less than 7. What is the problem? How can we find the answer to that question? So go ahead and think about it for a minute. Pop the first effective one. It's literally x. So this is the form that either it's less than or equal to little x. That's going to be 1. So in this case, little x is 5. So this is going to be 1 minus 0.98 raised to the fifth power. So go ahead and type that in. Now if x is raised to the ultimately set by poverty, and that's going to, so the mean 0.0. So therefore it has a defect. a random sample of 100 tires is tested for quality assurance. Calculate the following. So go ahead and try these problems. It's based on a previous problem. So what is the probability that x is less than 7? What is the probability that we're going to find a defective tire within the first 6 samples? So keep in mind, p of x, which is less than 7, this includes all numbers from 1 to 6. It does not include 7. So how do we get this answer? Now remember the formula that we used before. P of x less than little x is 1 minus q to the x. So right now, we have the less than symbol, but not the less than or equal to symbol. However, we can turn this expression into something like this, because this is 1 to 6. So we can say that p of x less than 7 is equivalent to p of x, which is less than or equal to 6. So now we can use this formula. So this is going to be 1 minus, now keep in mind, q is 0.98, and p is 0.02. So this is 1 minus 0.98 raised to 6 power. And that is going to be 0.11416. So there is approximately an 11.4% chance that the defective tire will be identified within the first 6 samples. Now let's move on to part B. So what is the probability that a defective tire will be found, let's say, beyond x is greater than 12? What formula can we use to calculate this particular probability? Let's draw a picture. So this is the shape of a geometric distribution. We have the probability on the y-axis, the random variable x on the x-axis. Now this is going to range from 0 to infinity. But for this problem, our focus is 12. This region here, let's separate it into 2 parts. The region on the left represents the probability where x is less than or equal to 12. The region on the right represents the probability that x is greater than 12, but not equal to it, since we included 12 on the left side. Now, the area under this curve from 0 to infinity has to equal 1, because that's the most that probability can be equal to. So if we add these 2 values, this is equal to 1. Now, what I'm going to do is, I'm going to rearrange this equation to get this one. But first, let's write it in terms of it's going to be plus add. So I'm going to erase this picture at this point. So we can say that the pressures need to be a final side to or add up to 1. This is of. So what's the probability that x before? So our goal is to cap. And so let's say 15 is here, and 30 is in this region. This is going to be 0, and that's infinity. So let's break this graph into 3 parts. We'll call it region A, B, and C. So the area under the curve for region A will be the probability where x is less than or equal to 14. For region B, that's what we're looking for. That's going to be from 15 to 30. And then region C, it's going to be beyond 30, so we'll start at 31. Now, these values must add up to 1, because the probability from 0 to infinity has to be equal to 1. Our goal is to calculate this value here. So let's rearrange the equation to solve for this expression. X is less than 14 minus p x is greater than 31. Instead of 30. These 2 expressions need to move to the equation to solve for this expression, which means these 2 expressions need to move to the other side. So I'm going to erase this picture at this point. So we can say that the probability of finding a defective tire from sample 15 to sample 30 is going to be 1 minus p finding a defective. So I'm going to erase this picture at this, which means, so let's rearrange the equation to solve for this expression, which means these 2 expressions need to move to the other side. So I'm going to erase this picture at this point. So we can say that the probability of finding a defective tire from sample 15 to sample 30 is going to be 1 minus p of x is less than 14 minus p x is greater than 31. Now let's get rid of this, and let's focus on calculating these 2 values first. So what is the probability that x is less than or equal to 14? So what's the formula that we can use for this one? So it's p of x is less than or equal to little x, and that's equal to 1 minus q to the x. So this is going to be 1 minus q, which is 0.98, raised to 14th power. 24636. Now let's calculate the probability that x is greater than or equal to 31. So this is saying that x is greater than 30, because that will still be 31 to infinity. So we're going to use this form. It's simply q to the x. So that's going to be 0.98 to the 30th power. Which is 0.54548. So now the final answer for this problem is 0.20816. So we can say that there's a 20.8% chance of finding a defective tire between sample 15 and sample 30. Now let's move on to the last part E. So let's calculate the probability in sample. I'm going to use this symbol here. Type E. In this video, we're going to talk about how to use the Poisson distribution formula in order to solve problems. So take this problem, for example. A small business receives, on average, 12 customers per day. What is the probability that the business will receive exactly 8 customers in one day? So the first thing we want to keep in mind is that the time interval is the same. It doesn't change. So thus the new textbooks will be is the inverse of the to the next with 8. Mu divided by x factorial. And the formula is mu raised to the x e to the negative mu divided by x factorial. So let's replace lowercase x with 8. So this is going to be 12 raised to the 8 e to the negative 12 divided by 8 factorial. Now, keep in mind, e is the inverse of the natural log function, and e is basically a number. It's 2.71828. 8 factorial, that's 8 times 7 times 6 times 5, all the way to 1. So if you were to plug this into your calculator, you should get, hold on one second, you should get 0.065523, which if we multiply that by 100%, that's approximately 6.55%. So that's the probability that this business will receive exactly 8 customers in one day. Number 2, a student receives on average 7 text messages in a 2-hour period. What is the probability that the student will receive exactly 9 text messages in a 2-hour period? So what do you think we have to do in order to solve this problem? Go ahead and try it. Now, there's something that you need to pay attention. Now, the only other thing that we need to find is x. We can clearly see that x is 9, because we're going to calculate the probability that the student will receive exactly 9 text messages in that 2-hour period. So we need to calculate p when x is not. So let's go ahead and plug everything in. First, let's write the formula. So as we said before, it's mu raised to the x, e raised to the negative mu, divided by x factorial. So x is 9, mu is 7, so this is going to be 7 to the 9th power, e raised to the negative 7, divided by 9 factorial. So let's type that in. So you should get 0.1014, which correlates to approximately 10.14%. So that's the answer for part A. Now, let's move on to part B. But first, let's get rid of this information. What is the probability that the student will receive exactly 24 text messages in an 8-hour period? So notice that this time, the time period is different. So therefore, the mean is going to change. The mean was 7 when the time period was 2 hours. What is the new mean value when the time period is 8 hours? So by looking at these values, you can see what it is. To go from 2 to 8, you need to multiply the 2 by 4. So therefore, we need to multiply the mean by 4, which will give you 28. 7 times 4 is 28. So that's the mean value. Now sometimes the math will not work out as nicely as what we see here. So you can set up a proportion. If you want a formula to do this, you can use this one. Mu 2 over mu 1, see that's 24 power, that's going to be all we see exactly to 8. And x is 7, since we want to calculate that. Probability. When I do that, stability, so all the way probability. E raised to the negative mu plus to the negative. So mu. So a nice 5 column or delay, not E. Let me use a different or then it's this side minus the end. But what I got even more so more than likely it's going to receive more than 6 calls in an hour if one actually receives 8. In this video, we're going to talk about the difference between continuous data and discrete data. Now, continuous data is data that can take on any value in an interval, whereas discrete data, but a connected line. All the data in this graph is connected, so this will be continuous. The second example will be discrete. You can easily tell because the points are not connected. You see a lot of discrete values. If you see individual points that are not connected, it's going to be discrete. So these three types of graphs they represent discrete forms of data. Whereas if you have a smooth line, it would represent continuous. In this video, we're going to talk about continuous probability distributions. So here's an example of a type of continuous probability distribution. This one is called the normal distribution. Now it has the continuous random variable x. X could be anything. It could be 2, it could be 3.5, it could be 4.68. It could be anything along the x-axis. Now if we had discrete random variables, x would have restrictions. It could be like 1, 2, 3, 4, 5. But when dealing with continuous random variables, x could be anything. It could take on any value. Now on the y-axis, we have the function f of x, which is also known as the PDF, which stands for the probability density function. Now f of x will tell us the height of the curve above the x-axis at some point x. So f of x will give us the distance between these 2 points. Now let's put some letters here. Let's call this A, B, C, and D. We're going to use that shortly, but one thing I do want to mention is that the total area under the curve for a continuous probability distribution is always equal to 1. So the area of the shaded region, highlighted in blue, that's equal to 1. So I'm going to write TA for total area. That's 1. Let's say if we wish to calculate the probability that x is less than a. How would you do it? What you need to do is calculate the area under the curve of every thing to the left of a. So it's going to be the area of the region shaded in red. Likewise, if we wish to calculate the probability that x is between b and c, what we need to do is we need to determine the area under the curve between b and c. Likewise, if we wish to calculate the probability that x is greater than b, so for a continuous probability distribution, you won't see the curve under the x-axis, it's always above the x-axis. Now, this question here, what is the probability that x is equal to b? What would you say?
Here.
Now, here we don't have a range of values. We simply have just a line at b. And for that, we have the probability that x is equal to the same. Now we need to get f of x value as from a distribution, continuous probability distribution functions. Now, we briefly talked about the shape of a normal distribution. There are some other continuous probability distributions you need to be familiar with. The next one is the uniform distribution. The uniform distribution has a constant f of x value, as you can see, and it ranges from a to b. Now, the area of the curve under the uniform distribution, or basically the area of the rectangle, is going to be 1. So let's say we have a uniform distribution from, let's say, 2 to 6. So a is 2, b is 6. If the area of the rectangle is 1, what is f of x? What is the value that corresponds to that point? Well, we know the base of the rectangle is 4. 4 times what number is 1? Because the area has to be 1. It's going to be 1 over 4. So that's going to be the value of f of x for this problem, for uniform distribution. Because if you multiply 1/4 by 4, you're going to get an area of 1. And so for any uniform distribution, the area under the curve has to be 1. So just keep that in mind. So now I'm going to give some formulas that from a to b probability density function after you plug in a and b, where b is 6, a is 2, you would get the function f of x is 1 over 4. So that's how you would incorporate this formula to calculate the probability density function for uniform distribution. Now the next thing you need to know is that the mean is equal to the average of a and b. So it's the sum of a and b divided by 2. And next is the standard deviation. That looks like theta, but it should be sigma. The standard deviation is the difference between b minus a divided by the square root of 12. So those are some formulas that you may want to write down when dealing with the uniform distribution, which is one of the types of continuous probability distributions that you need to know. Now, the next distribution that we're going to talk about is known as the exponential distribution. This is another continuous probability distribution that you want to add to your list. So it has a y-intercept, and then the function decreases over time, or with x. We have f of x on the y-axis, and the y-intercept is lambda, the rate parameter. The probability density function is f of x is equal to lambda e to the negative lambda times x. Lambda, the rate parameter, is 1 divided by the mean. So those are some things that you want to know for this type of function. And keep in mind the total area under the curve for this one or any type of continuous probability distribution function is always going to be 1. It has very basic things, but let's say if we have this point x, and we wish to calculate the area times x. Now, if you want to calculate the probability that x is greater than x, it's simply e to the negative some other. In this video, we're going to talk about cumulative distribution functions. The cumulative distribution function, or CDF, these functions are used to calculate the area under In this video, we're going to talk about continuous is the difference between b minus a divided by the square root of the a1 intercept function is the rate equal to the rate parameter. The probability density function is f of x is equal to lambda e to the negative lambda times x. Lambda, the rate parameter, is 1 divided by the mean. So those are some things that you want to know for this type of function. And keep in mind the total area under the curve for this one or any type of continuous probability distribution function is always going to be 1. I have to erase a few things, but let's say if we have this point x and we wish to calculate the probability that x is less than x. So that is the area shaded in blue. The formula for that, to calculate the area under the curve of that region, is going to be 1 minus e to the negative lambda times x. Now, if you want to calculate the probability that x is greater than x, it's simply e to the negative lambda times x. In this case, that would represent the region under the curve to the right. So those are some other formulas that you want to know. In this video, we're going to talk about cumulative distribution functions. The cumulative distribution function, or CDF, these functions are used to calculate the area under the curve, specifically the area to the left of some point of interest. Now these functions, they're used to calculate the accumulated probability. Now keep in mind, whenever you have a continuous probability distribution, the probability is equal to the area under the curve. And since the maximum probability is 1, the total area under the curve will be 1 as well. Now probability density functions are different from cumulative distribution functions. The PDF or probability density function is f of x, and it tells you the shape of the distribution. So for instance, let's say if we have a uniform distribution. In this case, f of x will equal a specific number. It's going to be a constant value. F of x is going to be 1 over b minus a for a uniform distribution. It's a number. It doesn't have a variable x in it. You'll see something that looks like this. So this is f of x, and it varies from a intrinsic x via b minus a varies to the left. So we have this one, the probability that the random variable capital X is less than or equal to some number is going to be x minus a over b minus a. So this function right here, highlighted in blue, this is the CDF. That is the cumulative distribution function for a uniform distribution. It gives us the area to the left of some value x. In a PDF, it's just f of x. For uniform distribution, that's 1 over b minus a. Now, let's talk about the exponential distribution. Let's discuss the CDF and PDF for this type of distribution. The exponential distribution, the maximum value is the y-intercept and it decreases over time. The maximum value is also known as lambda, rate parameter. The probability density function for an exponential distribution is going to take the parameter of the curve. shape of the distribution. And after that for this particular distribution is lambda e to the negative lambda times x. And lambda is the rate parameter. It's 1 divided by the mean. So this is probability density function. It tells you the shape of the graph. That's what it does. In addition, it also gives you the height of the curve above the x-axis at some point x. That's another thing that it tells you. Now the CDF gives us the area under the curve to the left of some value x. So let's say if we wish to calculate the area to the left. So that's going to be A out. That's going to be the probability that x is less than or equal to some value. And that's going to be equal to 1 minus e to the negative lambda times x. So that is the cumulative distribution function. It gives us the area under the curve to the left. So if we wish to calculate the probability that x is between 0 to x, or let's say 0 to a, this function will help us to get the probability. It's equal to the area under the curve. Now, if we wish to calculate the area to the right, as opposed to the area to the left, we know that the total area is 1. So the area to the right plus the area to the left must also be 1. So the area to the right is 1 minus the area to the left. And we know the area to the left is what we see here. It's 1 minus e to the negative lambda times x. Now, if we distribute the negative sign, that is this negative sign, it's going to be 1 minus 1, and then these two negative signs will cancel, giving us a plus sign. So plus e to the negative lambda times x. So 1 minus 1 is 0, thus the area to the right is going to be simply e to the negative lambda times x. Now, this is not the cumulative distribution function because it doesn't give us the area to the left. It gives us the area to the right. So the CDF is what we see here. That's the CDF for an exponential distribution. Now, let's say if we still have an exponential distribution, but we want to calculate the area between a and b. So we want to find probability of the eighth. So this is the probability that x is a single value. We need to get, remember, a normal. In this video, we're going to In this video, we're going to go over the standard normal distribution, as well as some equations that you need to be familiar with. After that, we're going to work on some problems so you can see how to put these formulas to good use. So the normal distribution has the shape of a bell curve. In your book, there it is. Distributions away from the mean will tell us that subtract those two. So what is the z-score that corresponds to a value? That corresponds to x equals 30. So if x is 30, what is z? So now we're going to use the rearranged form. In this video, we're going to focus on solving probability exponential distribution problems. So let's start with this one. In this video, we're going to focus on uniform distribution.
من الغم الله أكبر أشهد أن لا إله إلا الله لا إله إلا الله. لكن رب العالمين ربنا رب مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين واليوم يرتقون لا عبد من تعبدون ولا أنتم عابدون ما أعبد ولا أنا عابد ما عبدتم ولا أنتم عابدون ما أعبد لكم دينكم ولي دين سمع الله 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 أكبر الله أكبر الله أكبر الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين قل يا أيها الكافرون لا أعبد ما تعبدون ولا أنتم عابدون ما أعبد ولا أنا عابد ما عبدتم ولا أنتم عابدون ما أعبد لكم ولي دين قل يا أيها الكافرون إذا جاء نصر الله والفتح رأيت الناس يدخلون في دين الله أفواجا فسبح بأمر ربك واستغفر إنه كان توابا سمع الله من الله أكبر الله أكبر الله أكبر الله أكبر السلام عليكم ورحمة الله السلام عليكم ورحمة الله